Hello, welcome back to our channel. Today we are going to discuss about laws of motion part 2. In this we are focusing on the contact forces. So field forces are there, contact forces are there. Contact forces are nothing but tension, viscosity, friction, all belongs to, you can say that, contact forces. Internally these are acting this type of forces because of the contact between the two surfaces or between the contact between thread and body. We are observing these contact forces. But in this part we have to going to discuss about the what is the tension. Tension is one of the contact forces. It is the force exerted by the string or force exerted by the rope or force exerted by the thread. In any case, hanging thing, that too we are using either rope, string and cable. We are going to use the tension. So in our daily life, where we should observe this one, lift is based on this only. Here that lift is tied with one rope. Here force is exerted by the string on the lift. Here we can take the tension. So we are going to discuss about different cases in the case of lift. First one is, look here. If the lift is at stationary, means what? You are here, tension is acting upwards, weight is acting downwards. This is the action and reaction is on thread. Here acceleration equals to 0 means we can write it T equals to mg. Like that, if lift is going upwards, look this arrow mark, upwards with how much acceleration? A. So in this case, which is dominating? Tension is dominating the weight of the lift. That too, acceleration is acting upwards. From the Newton's second law, what is the resultant force here? T minus mg. T minus mg. From Newton's second law, you should write it ma equals to T minus mg. So no need of all these expressions. Simply you can remember that T equals to m into g plus v when the lift is going upwards. Like that, when the third case, lift is coming downwards with how much acceleration? A. Here also what happens? Weight is dominating the tension. Weight is dominating the tension. Why? The body or the lift is coming downwards. So here you can take it. Resultant force is how much? Resultant force, and after simplification, here anyway resultant force we are writing mg minus t. From this t equals to m into, this is the g minus a we are getting. G minus a. So in this case, even practically also we should observe when while going upwards, we feel like more weight like that. Why? Here tension is greater than weight. Here tension is equals to weight when it is at lift. Here tension is less than weight because here minus is there. So these are the different cases of the lift condition, how the tension is acting. And one more case is there, freely falling. Suppose the rope will break, at the time the body is coming or the lift is coming downwards with how much acceleration? G. Here tension we can take it m into g minus g equals to 0. No tension in this case. So these are the different cases. We do one problem also. Look here. If A equals to 4 meter per second square, G is the 10 meter per second square, mass equals to 2 kgs. Or you can take it 200 kgs. Find tension when the lift is going upwards to the ratio of the tension when the lift is going upwards to the tension when the lift is coming downwards. Simply you can take it, no need of mass cancel. While going up, what we are taking? This is g plus a by g minus a. So our answer is 10 plus 4, 14 by 6. This is the ratio of the two tensions. So depends on the situation we can use. This is very important, one of the very important concept. But while reading the problems, you should remember that the lift is going upwards or coming downwards. Is it freely falling or is it rest? Like that we should observe this one. Then we are going to discuss about Atwood machine. Atwood machine means we are taking two massive bodies are connected by the string. That string is passing over a frictionless pulley. Here what is the use of that pulley? It is changing the direction of the tension. Look here. This is the Atwood machine. This is the mass m1 and this is the mass m2. Here we can take it m2 is greater than m1. So it is going upwards with how much acceleration A. It is coming downwards with how much acceleration A. And here we should take one rigid support also. But here pulley is doing changing the direction of the tension. Here also it is acting tension towards the pulley, and here also it is acting towards the pulley. So in this case, what is the expression for acceleration and what is the expression for tension? First of all, we can go through the free body diagrams, then you can take it any type of the case, we can calculate the tension and acceleration. Look here, for first body, acceleration is acting upwards. We can take it m1a equals to t minus m1g. Second case, second body, it is coming downwards. Anyway, acceleration is m2a equals to m2g minus tension. After simplification, we are getting the tension equals to 2m1 m2 g by m1 plus m2. When you are substituting the tension in any case, what you are getting acceleration m2 minus m1 into g by m1 plus m2. We do one problem also. Suppose if m1 equals to 4 kgs, m2 equals to 8 kgs. What is the acceleration and tension? Tension what we are taking 2m1 m2, 8 into 8 64 into g 640 by m1 plus m2 is how much? 12. So 160 by 3 newtons. Tension is nothing but force, we are getting newtons. Like that acceleration m2 minus m1, 4 into g is the 40 by m1 plus m2 is the 12. After simplification, 12 by 6 it should be right, 10 by 3 also. This is the meter per second square. So this is belongs to the Atwood mission. If they will mention that two particles or two bodies are hanging, otherwise they will directly mention that Atwood mission means we should consider this case. And next application, look here. This is one horizontal surface. We are smooth horizontal surface. We are placing one block here. Same, we can arrange the frictionless pulley here. This thread is passing over a pulley. This mass is how much? m2. Here also we can take it m2 is greater than m1. So this is going towards the pulley with how much acceleration A. Here tension is the same, thread means same tension, but it is coming downwards with how much acceleration A. So in this case, what is acceleration and what is the tension? Look here, on this body tension is balanced by the force of the first body, so T equals to m1 into A. In this second body, what we are taking m2A equals to m2G minus tension, but already you know the tension, no? When we are substituting here m2G minus m1A. After simplification, what we are getting this acceleration A equals to tension. First of all, we are finding the tension is m1 m2 G by m1 plus m2. Like that acceleration is how much? When you know the tension, we can find out the acceleration also, because instead of tension we can substitute this m1 cancel. You are getting acceleration equals to how much? m2g by m1 plus m2. Like that we can go through the one problem. You try this one. m1 is 4 kgs, m2 is 6 kgs. Find the acceleration and tension. So like this we can find out, but while reading the question you should remember that they will mention one is placing on the horizontal surface, another one is hanging vertically. The base of this one is we can take the free body diagram, means first we can take the single body. See, single body, upward tension is acting, downward weight is acting. Even though the body is coming downwards means weight is dominating the tension, we are writing m2g minus t is nothing but resultant force. Resultant force, that particular mass into acceleration. Like that here there is no upward movement and downward movement. It is moving towards the frictionless pulley, means T equals to how much? m1 into A. We are using the same thread, means here and here both the cases tension is the same. Next application, here we are taking one pulley, but here combination is, look here, this side M and M2 masses are acting, but here the rope is different, here the rope is different, but these two are connected by the same rope, means same tension. We are taking T1 and T2, T1 and T1. But here when you are coming to this one, T2, it is T2 we are taking. Here how to find out the acceleration of the system? From this case easily we can find out. Tension is acting upwards. First of all, how to find out the acceleration? You remember one formula here. Unbalanced force or unbalanced weight by total mass of the body is giving the acceleration. So this side total weight is how much? M plus M, 2M. And this mass is how much? Minus M into G by. So 2M plus M is how much? 3M. So 2 minus 1 is how much? 1. So the acceleration is how much? A equals to G by 3. Like that, when you know the acceleration, easily you can find out the tension. Here this is going upwards with how much acceleration? A. T1 is dominating this mg. Same, we can take the free body diagram. T1 minus mg equals to, instead of a, G by 3. After simplification, T1 equals to 4 mg by 3. Like that, how to find out the T2? See, this is coming downwards, means mg minus T2 equals to mass into acceleration. Instead of acceleration, we are taking G by 3. Finally, you are getting the tension is how much? 2 mg by 3. Like that, we can able to find out the acceleration T1 and T2 with the help of the free body diagrams. Then we are going to discuss about another application. Look, here we are taking inclined plane. It makes an angle theta. Here also we are taking the frictionless pulley. Here we are taking one block of mass is M1. It is moving towards this. Tension is T. Here also tension is T. One more block we are taking M2. Here weight is acting downwards. In this case, the tension and acceleration, how to find out? Here you know that weight is resolved into two components. One is the mg cos theta. Another one is the mg sin theta. So while doing this application, how to draw the free body diagram of first one? No need of considering this upward and downward. Simply you can take it T minus m1g sin theta. And it is moving. It is moving with how much acceleration? We are taking m1 into a, first equation. When you are going through the second one, what we are taking? m2g minus t equals to m2 into a. After simplification, so whatever the figure, go through the free body diagram. Upward, what are the forces? Downward, what are the forces? Finally, you should observe that is it coming downwards or upwards. Then you should balance, and after simplification, here you are getting A equals to m2 minus m1 sin theta into G by m1 plus m2. This is the crash course, that's why I am not explaining entire expression, but you must remember these formulas are here. Then like the tension, you are getting 1 plus sin theta into m1 m2 G by m1 plus m2. m1 plus m2. Suppose in this case, this type of Atwood machine, we are getting the 2, but here another one we are taking 1 plus sin theta. If it is sin 90, we are getting 1 plus 1. Once again, you are getting the 2. We do one problem also. Look here. If m1 equals to 4 kgs, m2 equals to 6 kgs, theta equals to 30 degrees. Then acceleration is how much? Use this one. So m2 is how much? 6. 6 minus m1 sin theta. 4 into 1 by 2 is the, just you are getting the 2 into G by G value 10 by m1 plus m2 is how much? 10. So this one cancel, 4 meter per second square. Like the tension is how much? 1 plus sin 30 is the 1 by 2. m1 into m2 is how much? 240 into 10. 24 into 10, we are getting 240 by m1 plus m2 is, as usual we can take it 10. So T equals to, this is the 3 by 2 into 24. Answer is 36 newtons. Like that we can able to find out the acceleration and tension. And one more case we are going to discuss, that is we are taking two inclined planes, not single inclined plane. We are taking two inclined planes, and one is making an angle of inclination is the alpha, another one we are taking an angle of inclination is the beta. How we are taking? Look here. We are taking two inclined planes. One is the alpha another one is the beta, the M1, this is M1, this is M2. Here also we can take it M2 is greater than M1. In this case directly we are taking A equals to M2 sine beta minus M1 sine alpha into G by M1 plus M2. Like the tension you are getting sine alpha plus sine beta into M1 M2 G by M1 plus M2. Direct you should remember these formulas. Then we are taking one more application. You can take, this is the first block of mass is M1. One single rope we are taking. Here tension we can take it T1. This is the M2. Here tension we can take it T2. And another block of mass is how much? M3. And we are applying the force is how much? Because of the applying the force, the entire system is moving with how much acceleration? A. Here how to find out the acceleration? Force by mass is called the acceleration. So A equals to applied force by M1 plus M2 plus M3. Like the tension, this tension belongs to first one means T1 equals to M1 into A. If instead of A we can write this expression also. Like the T2 equals to how much? M1 plus M2 into A. Like that we can find out the T1, T2 and acceleration. The next thing is also contact force only. But here we are taking two blocks. First block of mass is M. Second otherwise M1. This is the M2. We are applying the force on this how much? F. Because of this reason it is moving with how much acceleration? It is moving with an acceleration A. Here how to find out the A? Same F by total mass of the body M1 plus M2. But here one contact force is acting between these two. That is the small f. That formula is M2 into A. Instead of A we are taking applied force by M1 plus M2 also we are taking. We do one problem also based on this. Suppose if M1 equals to 4 kgs, M2 equals to 2 kgs. In this case what is acceleration? A equals to applied force is 10 newtons. So A is the F by M1 plus M2. So 10 by M1 plus M2 is how much? 6. Like that contact force is M2 into A. M2 is the 2. Acceleration is 10 by 6. So answer is how much? 10 by 3 newtons. This is the meter square. But instead of 2 we can take it like this is M1, this is M2, this is M3. We are placing on the surface. We can apply the force on this. Here acceleration is how much? A equals to, instead of 2 masses we can take it 3. M1 plus M2 plus M3. Like that between these two contact force we can take it F1. Between these two F2. F2 equals to only this one means M3 into A. And F1 is how much? Both M2 plus M3 into A. So depends on the situation. We can able to find out the tension. Tension is the force exerted by this ring. And here in the case of connected bodies without rope also we can find out the contact force and acceleration is like this. I hope you understood this concept. Already I made laws of motion part 1 also. There I have explained Newton's first law, second law, third law and law of conservation of linear momentum. This is the second part I have completed. Then our next part is we are focusing on the friction. So try to do more number of problems, then you will get the grip on the subject. So in this crash course I have made day 1, day 2, that one. I think it is you can understand this one. Those who didn't subscribe, and you should subscribe, and then you are getting the playlist. From the playlist you should follow the day 1, day 2 like that. If you want any information related to the weightage, from the playlist only you can go through the weightage, and previous year's problems also I have made. If you want you can watch that videos also. Thank you everyone. Please share my channel to your friends also. Then it is supporting to me. Thank you everyone.